Hello guys, welcome to JTO tutorial trainings. My name is Ramesh. I have been working in Spark and Spark streaming related applications for quite some time now. So in this video, I'd like to share with all of you how to debug the Spark streaming application. So the first step would be to go to the Spark UI and go to the streaming tab of the Spark UI. So the screen which you are seeing right now, it's a Spark UI, and here there are multiple tabs which we can see. The first tab is the Jobs tab. This particular tab has all the information about the jobs. So as you can see, this streaming job has been running for 34 minutes right now, and you can see the active jobs count is 13. So active job means either the jobs which are currently going on or the jobs which are in pending, so which is in the pipeline, which are already submitted but not yet started. And the other information which you can see is the completed job. So these are the number of jobs which are already completed within this particular time, which is almost half an hour. If you scroll down, you can see that the number of jobs which are currently in progress and the completed jobs details. So these are all links which are provided to the particular jobs, which you can click on that and it will take you the job details page. Before that, I'd like to brief about the concepts of Spark streaming. So this is every Spark streaming job. It's a micro batch type of a job. So we can set the interval, the batch interval of this streaming job. So in this particular streaming application, I have set the streaming interval as 1 second. So and the input is a file streaming, and so this Spark streaming is looking for one particular folder in the HDFS directory, and all the incoming files which are coming to that particular directory, this application will monitor that directory, and all the new files based on the timestamp, it will pick it up and process it. What are processing we have applied on that. And finally, it will write into Apache Kafka. So this is all about this application which I am running on. And so there are, you can see these are the receivers. I have set 8 receivers for this streaming job. So there will be 8 different processors which will be looking into that directory, and if there are multiple files coming at the same time, parallelly these 8 receivers can pick those 8 files, and if that one huge file comes and one receiver picks one file, and if it's still streaming at that the streaming level, and if the next file comes within the time which is within the processing time of the first file, so that then the next file which is received can be processed by the other receiver. So in that particular case, I have kept 8 receivers over here. So next we will go to the streaming tab, and we will see what are the information available over there. So here I am clicking on this last tab, which is the streaming tab, and you will see what are the what we can see over there. So here we are in the streaming tab. So the primary information which we can see is that it shows the batch interval, the first of all. So it is saying that running batches of 1 second. So this is the batch interval. Every 1 second it will gather all the data from the input source and make one batch out of it. And the streaming layer will submit a Spark job with that much of amount of data which it received in the 1 second. and next to that it will show that how long this job has been running, and what time it has started. So the coming to the next the big blocks which we can see it over here, the graphs and all. So the first one is the input rate. So here you can see, as I explained earlier, there are 8 receivers I have configured, and it's showing that 8 out of 8 receivers are active, and it shows the average the number of events which we are receiving through these receivers. It shows that around 2000 events per second. So here it shows that ups and downs of number of events which are coming through the input receivers. Also, it gives a nice histogram over here. We can derive some insights from that. So, and if you click on, this is a expandable link. If you click on that link, it will show the statistics of each particular receivers. So I have 8 receivers, and so here we can see that each receiver is picking up different files. So one file receives, and this function receiver 0, it picks it up, and it streams at this particular speed. And so like that, likewise the whole, and you can see that 2 of those receivers are lying idle. So it all based on the number of files which you are receiving in particular interval. So coming back to the next major block, which is the scheduling delay. Currently we have the scheduling delay as 0. So I will come to the scheduling delay. I will circle back to it after once I finish the processing time and the total delay. So we'll skip over scheduling delay and we'll come to the processing time. Processing time, it's, as you would have guessed, it is nothing but the processing time. So currently we have one batch timing, that is 1 second, and we can see that the average processing time of one batch, it has taken 46 milliseconds, which is very good. So ideally we should keep looking at this processing time, and it should be within the batch interval. So currently we have batch interval is 1 second, and this is 46 milliseconds, so that is fair enough. So you could guess that what will happen if processing time is more than the batch interval. So it will be, the jobs will be taking more time to complete, and there will be more and more jobs will be queued, but eventually that the jobs will get piled up, and finally the streaming job will die. And so now you got the understanding about the processing time. Now coming to the scheduling delay. So suppose you imagine a scenario that the processing time it is taking is 2 seconds to process one batch, and our batch interval is 1 second. So every 1 second there will be a new batch, which new job is getting submitted to the queue, and one job is taking 2 seconds to complete. So there is a delay of 1 second, right? Assume that there is only one thread which is doing the jobs, which is doing the work. So first we submitted one job, and it took 2 seconds to complete that. But after 1 second, there will be one more job which will be submitted, but that will not be start getting processed. So there is a delay of how much? 2 seconds minus that batch interval 1 second. So that is the scheduling delay. That is the delay by which the next job is waiting to get picked up by the executor. So in this case, since our processing time is well within the batch interval, our scheduling delay is 0. And when it comes to the total delay, so total delay is nothing but the sum of scheduling delay plus processing time. So as you can see here, the scheduling delay for this particular thing is 0 and processing time is 46. So if you add up these two things, we will get this total delay. There is nothing more to it. And here the next major block you can see is the active batches. So here this is the number of batches which are currently in progress or which are waiting in the queue. Let me try to refresh if any batches are getting there. So it will be keep on changing and it will be dynamic. So the batches will get finished very quickly. As we have seen, the processing time is quite low, less than 46 milliseconds. So we cannot see it here. If you keep on refreshing, probably you will be able to see 1 or 2 over here, and you can see the completed batches over here. So, and the next thing we will see. So here there are lots of information we can see. The input size, the number of events which constitutes this particular batch, and the scheduling delay, as you see, in the most of the times it's 0 processing time, total delay. Yeah, so if you can click on one of these links, it will take you the detailed view of this batch detail view. So let's go there and see. So this is the batch detail view. You can see that here also once again it shows that the duration of this batch, it is 1 second, and input data size, scheduling delay, processing time, total delay. So these all things we have already seen that. And if you see the output operation duration, it's again the processing time. In this particular the application, there is only one stage for one job. So you can see that the job ID over here. If we click on this job ID, it will take you to the job details page. Let's go there and see what is there. So we are in the job details page, and the status, it shows that it succeeded. So this is already completed job we have seen. Here this is a DAG diagram, this visualization of the DAG, which is the directed acyclic graph. You can see that there are 8 different inputs, so 8 receivers which are reading files from the HDFS. So I have this map application, my map operation immediately after this receiver, and I do a union of this all these RDs after that. So that's what we are seeing. So I get the RD, or rather let's say the D stream. So I'll build a D stream from the receiver, and immediately after that I'll apply a map operation. Then I will put a union of all these D streams, and further again some sort of transformation I'll apply on top of it, map values, map partitions, and some sort of it. And here I am doing a caching over here. You can see there is a green dot over here. So if anything you see it in green, that means there is a kind of the RDD or the D stream is getting cached there. So you can see that it's a parallelly 2 different operation is happening. So here I am applying a filter, and for certain particular types of events I need to apply some sort of mapping operation on that, and for remaining events I do not need to do that particular thing. So these are 2 parallel operations that are happening, and once that is completed I will do once again the union and to do the output operation to the Kafka topics. That's what we understand from this DAG visualization. So again this will be going back to the completed stages information. So here also this is like a one-to-one mapping for this. There is one job directly mapped to one staging, but depending on how your application behaves, there could be multiple jobs in one stage. So let's click on this and see the details about the this stage. So here we can see the total time across all the tasks. So there are so many tasks which are which will be there in one particular one stage. Here we can see there are total 40 tasks in this particular stage, and it also shows that how many executors are there. So here in this case there are you can see that 39 executors are there, and this is the primary one thing you can verify that your Spark is doing parallelization in the correct way or not. So here you can clearly see that it's getting distributed to multiple